Hey, grade 5. Now, as I've been going over concepts that we've also covered in class, I've had a few students ask me about long division and say they could use a refresher on it, so let's do that. Now, actually, the very first video I ever made back over 4 years ago now, as my first year as a teacher at Samuel W. Shaw, was about long division. So if you want to go back and hear an older description, as well as my white math teacher rap abilities, then check out the link to the old video that I'm going to put into the description of these. But that said, that was my first year as a teacher, and I'm much better at explaining things now than I used to be. So hopefully this video is useful to you as well. It's a little more clinical and it's more laid out, but it's also hopefully more direct and more comprehensive for the subject. So let's get started on that. Now I'm going to do two separate videos. The first one is grade 5 level. This shows us how to do long division and end up with a remainder. The second part, that's going to be a separate video and have this same intro, is a demonstration of how we can go even further, talking about using long division to get fractions or even decimals instead of remainders. Alright, here goes. Now this second video in our division series goes into one of my favorite things about long division. It lets us turn fractions into decimals by hand. And in the same way, if we have a problem with a remainder, we can turn that remainder into a decimal by hand as well. Long division is our ticket to no more remainders. And here's how that works. Now first, we're going to need to shout out that fractions are actually division. To any adults out there, this shouldn't be news, but to students, this is always a mind-blowing thing at first. Let's talk about what we know about fractions. Fractions are a whole split into an equal number of parts. Let's think about division. We have a group of things that we're splitting into a number of equal groups. A whole split into equal parts. The concept's exactly the same. Equal parts of a bigger thing. Let's take a really basic example. If I have 9/3, I have 3 wholes. 3/3, 3/3, and 3 more thirds. 9/3 is the same as 3. 9 divided by 3 is exactly the same. This has been hidden in the division symbol the whole time. It's actually just a fraction with placeholder dots. Let's take a look. Let's look at this example here. Now on top, am I looking at 9 things grouped into groups of 3? Or am I looking at thirds, 3 groups of 3/3? Well, either way, 9/3 and 9 things grouped into groups of 3, I have 3 things at the end of it. 1, 2, and 3. And we can see how this has been hidden in the division symbol the whole time if we just move some parts of it around. 9 divided by 3 is 9 thirds. It's always been there. Alright, so what's this have to do with long division? Well, let's take a problem that doesn't seem like we'd need long division for it at first. Something like a dividend of 25 and a divisor of 8. 25 divided by 8. Now, under normal circumstances, I'd look at this and, well, I know my 8 times tables. I know 3/8 are what's going to fit into 25. I know I'll have a remainder of 1, because 3 times 8 is 24. Starting now, though, I don't want to be done if I have a remainder. I know, thanks to fractions, that it is possible to have a whole split into smaller parts. Let's see what happens here. Well, 8 doesn't go into 2, so I move on to look at the whole number altogether. 8 goes into 25 3 times. 3 times 8 is 24. I subtract. I have a remainder of 1. So, up to this point, and at the grade 5 level, you'd probably write 3 are 1. And I'd give you a check, and you'd go on your way, and everybody's happy. If you'd really like a challenge, however, we can keep dividing that 1. I'm going to want to split that 1 into 8 parts. My 1 remainder, if I keep dividing it, means I'm going to have equal parts that are each 1/8. 1 split into 8 equal parts. So I can write my remainder as a fraction, my remainder over the denominator that is my divisor. My actual solution, splitting 25 perfectly into 8 equal parts, should give me 8 parts that are each 3 1/8. Alright, so far hopefully that all makes sense. Now, knowing that remainders are fractions, we should also hopefully know that we can write a fraction as a decimal. Fractions are parts of a whole, reduced to the simplest numbers we can use, while decimals are parts of a whole written in such a way that we can talk about them using tenths, hundredths, thousandths, etc. Place value we're used to. Things that fit nicely into that system. It can be kind of hard to wrap our heads around how and why this works, especially when we start getting beyond the obvious ones. Everybody knows 1/2 is 0.5, or 5/10 if we're reading it properly. Most people know 1/4 is 0.25, 25 hundredths. The thing is, long division can always give us a decimal from any fraction. Let's take a look. Now, our example problem from earlier had a remainder of 1/8. Now we know that that could also be 1 divided by 8. My dividend is 1, and splitting one thing up into equal parts. My divisor, the number of parts I'm splitting it into, is my denominator, 8. Now, pretty clearly, 8 does not fit inside 1. So we can't use this traditional way of doing it, but we can use the long division bracket. One divided by 8. So what the heck do I do? Well, think about it this way. Does saying 1 0/10 mean anything different than saying 1? Well, no. I'm saying I have 1 whole and 0 of something else. What if I put a 0 here? 0/10 behind a decimal. I have 1 whole and nothing else. I could also have 0 hundredths. I still have 1 whole and nothing else. 0 thousandths. I could have 0 10,000ths. I could write zeros forever behind the decimal without changing that I have one thing and nothing else. But now that I've got all these extra zeros to work with, I can actually long divide. Let's take a look. 8 goes into 1 0 times. So I put a 0 in my ones place. Now I'm going to start getting parts that are smaller than 1 whole. But I can do that. I just need to remember to put a decimal up top. Now, 0 times 8 is 0. I subtract 0 from 1, and I still have 1. But 1 whole is the same as 10 tenths. And now I'm dividing into my tenths place. How many times does 8 go into 10? Well, that's 1. If I split 1 whole into 8 equal groups, each of those groups will have 1/10 in it. And yes, there will be a remainder. 1 times 8 is 8. I subtract that and get a remainder of 2 tenths. Whew! Alright, next, 2 tenths, well, that's 20 hundredths. Thankfully, we've already done place value this year. I bring down that 0, and I can divide 20 by 8. 8 goes into 20 twice. 2 times 8 is 16. I subtract, and my remainder is 4 hundredths. Well, 4 hundredths is, yes, 40 thousandths. How many thousandths do I get if I split 40 of them up into 8 equal parts? 40 divided by 8 is 5. 5 times 8 is 40. And now I have no remainder. This tells me, since I have no remainder, I'm done. I can't divide this any further. I would just be dividing 0 into 8 parts for eternity, which is always going to be 0. So 1/8, 1 divided by 8, is the same as 0 and 125 thousandths, 0.125. Now, there are some cases where my fraction is one that will not end. And I'm not going to cover those right now, except to say really briefly, if I ever get the same remainder twice, I know my decimal will start to repeat itself. So, if you ever get the same remainder twice when dividing a fraction, you have a repeating pattern in your decimal, call it quits there. Just draw a dot or line above the decimal to show it repeats, and walk away. Let's look one last time at the problem I started all of this with, 25 divided by 8. Now, instead of 3 1/8, I can keep dividing. I've already done this division, so I'm not going to walk through every step of it again, but I will remind you. Here's what it looks like. 25 is the same as 25 with a 0 behind the decimal. Now I can bring that 0 down, put a decimal in my answer, divide 10 by 8 is 1. 1 times 8 is 8, remainder of 2. Need to keep going, another 0. 20 divided by 8 is 2. 2 times 8 is 16, remainder of 4. Still have a remainder, need another 0. 40 divided by 8 is 5. 5 times 8 is 40. No remainder. I'm done. 25 divided by 8 is 3 and 125 thousandths. Or if I'm being informal, 3.125. All finished. And that's it for our advanced long division video. Those who were looking for a challenge, I hope this has helped you understand the value of long division for this type of problem. Good luck, grade 5. That's the divid end of this video. Peace.